Welcome to The Explainer. Today we're digging into something pretty wild, a hidden connection that totally rewrote the rules of science. So let's just jump right in. Think about this for a second. The ancient Greeks, right, the masters of geometry and logic, why on earth were they seemingly afraid of a concept like infinity? It feels like a total paradox. I mean, they gave us mathematical proof, but then they drew this hard line in the sand, saying some things were just off limits. And untangling that puzzle, well, it reveals this incredible, invisible link between two things you'd never think go together: math and, believe it or not, theology. You see, for the ancient Greeks, math was all about certainty. It was the study of the definite, the clear, the things you could absolutely pin down. But modern math, it's pretty much the opposite. It's built on the very things the Greeks wouldn't touch with a 10-foot pole: infinity, chance, and motion. So while they gave us this incredible gift of rigor, they also built this conceptual wall, basically saying numbers can go this far and no further. So the big question is, what changed? How did mathematics break out of that box? To really get it, to understand this massive shift in thinking, we've got to first look at those boundaries, the lines the ancients just would not cross. Okay, so their core idea was actually pretty simple. For them, the world is as it appears. What you see is what you get. So if a concept like chance or the boundless seemed ambiguous or fuzzy to us humans, well, that's because it was fundamentally fuzzy. And trying to use the razor-sharp tools of math on something inherently blurry, that was just impossible. It's like trying to measure a cloud with a ruler. But then, between the ancient world and the 17th century, everything changed. This entire way of thinking got turned on its head. And what's wild is that 5 of these forbidden concepts were one by one conquered by math. And when you line them all up, you start to see this incredible pattern emerge. All right, first up, the infinite. The Greeks had a word for it, aipiron, but this wasn't our infinity. It was just a big, messy bucket for anything that was boundless, vague, or just blurry. Pure chaos, really. But what modern math did was amazing. It was like a conceptual surgeon. It reached into that messy idea, split it apart, and carved out this incredibly precise, well-defined concept of infinity that we could actually work with. It brought order to the chaos. And, they did the exact same thing with chance. The Greek idea of tyche was all over the place. It was luck, it was fate, it was a random dice roll, all mixed together. That was stuff for the oracles, definitely not for a mathematician. But then, snap, that idea got split too. Fate was kind of pushed over to the philosophers to worry about, while randomness was refined into this narrow, precise thing that, boom, became the basis for probability theory. This next one is a little more subtle, but it's huge. So the Greeks obviously had problems with an unknown number. They called it arithmos. But here's the mental block. Because they didn't know what it was, they felt they couldn't do anything with it. You can't add something to I don't know, right? That was their logic. The genius of algebra was inventing X, a simple little symbol that let us pretend the unknown was known. It let us operate on it, move it around, and that just unlocked everything. Okay, what about emptiness? To the ancients, their concept of kanon, or the void, was just a problem, a philosophical headache. I mean, what do you do with nothing? It has no properties, nothing to measure, nothing to study. But then came people like Newton who looked at that nothing and completely reimagined it. It wasn't a void anymore. It was space, this active, structured mathematical stage where all of physics happened. It went from being an absence to being a fundamental thing. And last but not least, the very idea of change. For the Greeks, kinesis was this huge, sprawling concept. It meant a rock falling, sure, but it also meant a plant growing, a person getting old, a leaf changing color, all of it. Way too messy for math. So what did Galileo do? He did that same trick. He narrowed the focus, zeroed in on just one tiny slice of change, local motion, just an object moving from A to B, and suddenly he could describe it perfectly with equations. So you see the pattern here, right? It's so clear when you lay it all out like this. In every single case, you have this big, broad, kind of vague idea from the ancient world. And in every case, it gets split in two. A narrow, super specific piece gets carved out. And that piece, that precise little fragment, becomes the foundation for a whole new branch of mathematics. It's the exact same move, 5 times in a row. So why? What was driving this systematic shift? It wasn't some new theorem or some brilliant mathematician finding a new formula. No, the key to this whole revolution was something much deeper. It was a fundamental shift in worldview, a whole new philosophical backdrop for science. and it came from the most unlikely place you can imagine: monotheistic theology. Okay, to really nail this down, we need two quick ideas from philosophy. Don't worry, they're simple. The first one is called ontology. All that means is the study of what's really real. It asks the question, what is the true nature of the world separate from how we see it? And the second one is epistemology. This is about knowledge. It's not about what the world is, but what we can know about it. What are the limits of our human minds and our senses? What can we actually grasp? Okay, now, this is the absolute crux of the whole thing. For the ancient Greeks, those two concepts, ontology and epistemology, were basically the same thing. The world is how we perceive it. If it seems messy, it is messy. Simple. But then the monotheistic worldview comes along, and it drives a massive wedge right between them. It introduces this idea of a perfect, orderly, determined reality created by an all-knowing God, and then there's us, with our flawed, limited, human view of that reality. Suddenly, there's a gap. And that gap, as the scholar Ladislav Kvasz puts it so perfectly, is everything. This quote just nails it. It's this new space between what's really real and what we can see that changed the game. It basically gave scientists and mathematicians permission to say, okay, I'm not going to describe our foggy human perception of the world anymore. I'm going to aim my tools at the perfect underlying reality that I know is there. And just like that, everything flips. Concepts that seemed totally blurry and off-limits to humans could now be treated as perfectly clear and determined from this new God's eye view. From that perspective, a dice roll isn't really random. God knows how it'll land. The value of X isn't really unknown. God knows the answer. Infinity isn't chaotic. It's a perfect, divine idea. You see what happened? All of the fuzziness, all the ambiguity, was taken out of the world itself and placed squarely inside our own limited human minds. All right, so let's bring this all home, because this isn't just a cool history lesson. This surprising link has some really big implications for how we think about knowledge even today. So here's the bottom line. A huge shift in theology, a cultural belief system, literally created the philosophical playground that modern math needed to even exist. By splitting reality from our perception of it, it unlocked whole new worlds for science. And the really big takeaway here is that our deepest, most basic assumptions about the world, they're not just passive ideas. They actually draw the boundaries of what we think is even possible for science to know. They don't just help us find answers. They decide what questions we're allowed to ask in the first place. And that leaves us with one final, pretty mind-bending thought to chew on. If a single theological shift could completely redraw the map for mathematics, then what about us? What invisible beliefs, what hidden worldviews are we carrying around right now that are defining the limits of our science? What incredible frontiers might be sitting out there, waiting for us, just on the other side of a boundary we don't even know exists?